Okay, I got a little bit more work done, so I got it all somewhat cleaned up and mounted all the driver boards and the microprocessor and some relays and power supplies up. So we have it all set up and programmable. I mean, I can go run it real quick here. Just hit reset. So you have tidal volume. It's set. It's incremented. You can increment it every whatever you want. I made the array at 50 milliliters increments from 200 all the way to 800. So, and that's because not every BVM bag has the same displacement for the amount of travel on the stroke arm. So what you basically will have to do, depending on your bag, it's in the software that I have, is an array, and you just pair up the numbers for whatever stroke length your volume displacement is. So you have to take measurements. I only did every 50 because there's no sense in doing one for a smaller scale because I don't have an accurate volume meter other than a spirometer, which it's not that accurate. But once I get the software respiratory rate, I still need to set up the timer function in the software. That's just typing. Inspire, expire ratio, it's just adjustable, and I put also an e-stop in, and you just reset here. So it'll go in 4 times as slow out as it goes in. So, and I've been trying to find code that's been released yet for an Atmel-based chip, and I really can't find anything out there. So that's why I wrote the basic script. But once the other open source ones become available, it would be just as simple as uploading it to the microcontroller. And we still need to incorporate the pressure sensor in a closed loop for feedback. And I would love to have the analog or digital volume meter feedback too. That would be awesome. So, but problem with the pressure sensor, they're all out of stock, and due to the trade embargo, they're kind of hard to get from China, and that kind of complicates the things. I have a couple of pressure sensors that I used from a project decades ago, basically, that I could use. They're relatively small. Oopsie daisy. There we go. It's a very small sensor, but yeah, it has the barbed hose fitting. It's I think it goes down to a range in the point, decimal scale of the PSI, so it might be sufficient. I'll have to see how that works. And again, once I get the software all set up, you can take the bag off. Let me stop this for a second. There we go. So let's see, a bag just snaps out real quick just in case the machine stops. I still need to wire up an alarm and everything else. Probably add some more feature buttons if you want an adjustable dwell time. We can just put another knob in there. And any physician has any other ideas how they would like it programmed or inputs. Like I said, the mechanical and electrical parts are done except for the 2 more sensor inputs that I would like. And then it's just the basic programming stuff, which is not my super expertise. I'm kind of like a fat finger typer. It takes me forever to get something done. So somebody that's in the software engineering field could definitely do a lot better than I would. So once this proof of concept is all done, we can actually do it I'll do a new model, and this was all done with basically scrap metal off one of my CNC mills. There was sacrificial plates that were mounted underneath work. So the rest, this was not done with CNC. This was all done basically with, you could do it with hand tools, very simple. No plastic. Bearings are bronze, or you can use Delrin or Teflon, whichever your flavor is. And I'll post some pictures of how I did it. But very easy to build. This was built in the mechanical part, designed in one day. And figuring these things will do about 60,000 cycles a day. I'm not a big fan of 3D printed plastic, so this I'm sure would probably last quite a bit longer. So also you can see the that's the homing switch back here, which sends a signal to set the counter to 0 for the encoder. So it's based on the as I said in the previous video, has an optical encoder in the back, which one turn at the front is 150 counts, and it's closed loop, so it'll home into this position perfectly and then go back, form back, form back. If it loses track over the day, it would hit the home switch and reset to 0, but it's the same what's used in industrial application. And that's it, guys. So I'll keep you guys updated once I get the next model done. I might do a CNC version of it with ball bearings. That'll be a little fancier. But as I said, this should be, once somebody can program the rest of the medical criteria, and that should be functioning. So just be careful, unless you're a physician and know what you're doing. I wouldn't use this on anybody. My main purpose is to help people, not to harm people. So let me know what you think, and thank you guys. Bye-bye.